Okay, we now pick up with part 2 of exploring domain and range in our journey with functions. In the last video, we were looking at how to find the domain and range of our first two representations of a function, a list of ordered pairs and a given formula. We discovered it was pretty easy to find the domain and range given a list of ordered pairs, and it required a little more thought to find the domain and range given a formula. I think you'll find it's pretty straightforward to find the domain and range of a given graph, and again it's a little tricky to find it for a function that's described in words. Alright, let's start with looking at a particular graph. Okay, so here we have a graph, and remember that the x-axis represents the input values, or the horizontal axis I should say, and the vertical axis represents the output values. Okay, so any point on the graph represents the input and its corresponding output, described by my function. Alright, so we need to find all the x values that are represented in this graph. We see that starting here at x equals -2, we have a point on the graph that corresponds to it, and we can continue to have points on the graph as we go towards the right, and this arrow indicates that it goes on forever, thus our x values go on forever. So our domain here, and notice that to the left of -2, or when x is less than -2, we have no x values represented on our graph. So the domain starts at -2, we use a closed bracket to indicate that we include -2, and goes off towards infinity. We always have an open bracket on infinity because we never reach it. Okay, so the range will be the y values represented in my graph. So we look for where the y has an associated point on the graph. We see there's no negative y values represented, and we actually begin right here at y equal to -1. I'm sorry, when y equals 1. When y is 1, we do have a point on the graph, so we include y equals 1. And as we go up the y-axis, we see that there is always a point on the graph that corresponds to any value we choose. This arrow indicates that it goes up forever, so we know our y values are represented up forever. So our range is 1 to infinity. Let's look at another graph that actually has a break in it and see how we handle that in talking about the domain and range. So we have this following piecewise defined function, and let's see which x values and y values are represented. So let's start over here in the left in the negative realm, and we see that so here's -1, -2, -3. At x equals -3, we have our first point on the graph. To the left of -3, we have no representative, and we do include -3. So we know -3 is corresponds to a point on my graph, and that is true all the way up to -1, and including. We have to stop there because between -1 and 0, we have no representatives. So no x values between -1 and 0 get mapped to my graph. Now starting at 0, but that open circle tells us not including 0. We pick back up and we go on, and this arrow indicates that we go on forever towards the right. So towards positive infinity. The way we add our intervals is we use the union. Okay, so this is my domain in this particular example. Alright, so the range, we now need to figure out the y values represented. So we stop here, or we begin here, I guess you could say, at 1, 2, 3, 4, -4, and including. I have no arrow here, so I can't assume that I go down below. And I go all the way up to y equals 0 and including. Then I have a break between 0 and 2, and I pick back up at 2, and that's it. So 2 is the only one represented. Now, even though 2 is not on my, or y equals 2 is not present when x equals 0, it is for all these x values. So 2 is in my domain. When we include just one element, we use set notation. So it's the interval from -4 to 0 plus y equals 2, and that represents the range of this particular function. Okay? Alright, now let's look at an example where we're given a function described in words and see if we can figure out what the domain and range are. So let's look at this particular scenario. Sarah wants to rent a booth at the school-wide bake sale. The cost to rent a booth is $10. She can sell each cookie for $2 each. Describe a function whose input is the number of cookies sold and the output is the money earned. So let's write that down. Input is the number of cookies sold. So let's give it a variable name. Number of cookies sold. We'll say X. And the output is going to be money earned. Now let's see if we can figure out a rule for that. But before we do, let's talk about the input here. If we're talking about number of cookies sold, does it make sense for X to be negative? It does not. It doesn't make sense to sell a negative number of cookies. Does it make sense for X to represent a non-integer value? For example, 1/2. Can we sell half of a cookie? It doesn't really make sense. We can sell no cookies, so X equals 0 is a valid input. Alright, so what we should say here about our input is that we have non-negative integers. That makes sense in this problem. Alright, so the money earned. Well, we're going to earn $2 per every cookie we sell, and then we have to subtract off the cost of that booth. So 2x minus 10. Now let's see what our output is. And I like to do that by making a chart to help let me figure out what's going on here. We know that we can start at 0. We can't go to a negative value for x. But if I start at 0, that is I sell no cookies, well then I'm out $10 for the cost of the booth. If I sell 1 cookie, then I'm out $8. 2 cookies, I'm out $6, and so on. And we see that if we go up to 5 cookies, we actually break even. We have to sell more than 5 cookies to start making a profit. Okay, but this column over here represents our output values. And notice I start at -10 and then I go up by even integers from there. So we have made sense of what's going on in this problem. Let's see if we can write what it means in terms of the domain and range. So the domain is a set of non-negative integers. And there's many ways that we can write that, but writing it in words is fine. So non-negative integers. The range is the set of even integers beginning at y equals -10. Notice I said y this time because I'm talking about the range and not x. So I guess to summarize or to restate what we should do when we're given a function in terms of words is you should write out all what it means in whatever way it makes sense to you. Making a table is a good idea. Just kind of talking it through with somebody. What does it mean to have particular values of x? And then from there you should be able to come over and write the domain and range of the given function.